Hello. Yeah. So let's restart. So we were trying to talk about is a series of that looks like this, right? One half, one by fourth, one eighth, and one sixteenth, and this. So we clearly observed that A is equal to one and R is equal to two for the series. And what we said is every time R is less than one, then every consecutive term becomes a little bit smaller, right? So this is half as big as the first term, this is quarter as big. So when we try to write the sum for n term at a time, meaning this, that only if we say this is the first sum of the first term is 1, sum of the first and the second term is 1.5, 1 plus half, and then 1.75. Moving on, this is 1.75, this will be 8. Hmm, this would be 875 and then so on. We see that it looks like if you were to take a guess and then this would keep going and then what would do you think the sum of n terms would be when this goes to infinity? So I want you to take two guesses there. This is the nth term, right? The top one. So this is the first term, second term, third term. I want you to guess what will be like the infinite term here. And then the other thing that I want you to think about this, what is the sum when n becomes infinity, right? So you want to start with one half, one and a half, 1.75, and then you want to take a guess what this approaches. Okay, take some time to think about it. Okay, I think it looks like these numbers. If you try to write it down, the first number is 1, the second number is 0.5, then 0.25, then 0.125, then 0.0625, and 0.03125, and then so on, right? It looks like the numbers are getting smaller and smaller very fast. So it looks like when that infinite term comes, our guess it should be zero, right? Like maybe like they become so small that it actually ends up to be zero. So we say that every time that r is less than 1, then the consecutive terms decrease, then ultimately the series will go down to 0 if r is less than 1. So this is what we call this is what we call an infinite geometric progression, right? So there are infinite terms in it, but with r less than 1, right? What that means is it will, and these, whenever this happens, okay, we'll also have a finite sum here, right, which we want to discuss. So if you were to take a guess, just try to take a guess and let's see what it is, what this number will be. Okay. So in that case, let's try to find what the sum is, but let's try to work it through a formula first. So let's go to slide 17 and then let's try to work it out. So our objective is to find this sum, but we are going to take the longer way route out, right? We are going to derive a general result and then try to apply it as a special case. So our first term is a, second term is a times r, then a times r square, and then a times r to the power of n minus nth term, but then it keeps going, right? We have a to the power of, this is n plus 1 term, right? Was nth term, this was first term, like that. And then you keep going, and then you finally say that this will keep just going on infinitely, and this is what we need to find. So the difference between what we're doing here and what we did before is we only considered till this point earlier, right? But now we are already also having more terms. And of course, we need to assume that r is less than 1 in this discussion that we are having. Okay. So s times r in this case, then again we do this shifting thing that we do. So the first term is a into r when we multiply this with r, but when we'll write it one step forward, and then plus a into r square, which is comes from here, and then so on and so forth. We will also have an nth term which actually comes from the n minus 1th term here, a to the power n minus 2, right? The term here, and that multiplying that with r gives you the nth term, and then you keep going, a to the power of n plus 1, and then so on. Okay, now you just subtract as before, right? And all of these terms get cancelled, and then they keep getting cancelled till infinity, right? So what you're left with is 1 minus r times s, and then all you're left with on the right hand side is just a. So the sum that you get is a times r minus 1. So this is a very important formula, and it looks like a very clean and easy formula to remember, right? So what it's telling us is if there is an infinite sequence, so let's take an infinite sequence like uh, let's try to apply this formula now to the previous result that we had seen before. So now let's go back and now let's see what is A and what is R here. So here, this is written right here in the blue box that I'm drawing. So A is 1, R is half. So now we come back to slide uh, 17. Also, you can open the Jamboard link to the side. It will help you. Okay. So we are trying. So A is 1 in our case and R is half. So in that case, S is equal to 1 by 1 minus half, right? So what you get is 1 by 1 by 2, which is equal to 2. And that seems, so this is what it's telling us that the sum is 2. So let's check whether the sum is 2 or not. So it looks like the sum is becoming a little bit bigger, and then but then the next consecutive to sum might not be as much bigger. So let's try to quickly make it into Excel. Okay, let's try to see if that makes sense. So we have 1, 2, then 1, 1 half. So let's try to write it as a formula saying that this above divided by 2 is the next one, right? So we just drag it down saying that. So if we see that these are the numbers that we are getting, right? So 1 half and then it is becoming smaller. So let's also try to write this is this. Now this is our sum column. These are our terms. So this is the sum and its term sum. So now this is just the above sum plus this guy. So this is what we have done basically. And then and you can see that because there is not enough precision, like it is slowly getting higher and then it is becoming this, right? So let's also try to plot it so that we quickly have some visualization about how it is happening. We just want a line graph. 1, 2, 3. This is just the number, the nth term. Which one? What is the nth term? How do you create a line graph? Right from here. So let's remove this. So let's try to add that again. Yeah, a little bit messy, but hey, that's okay. Yeah, so you can see that okay, it starts from 1 and then it finally rises to exactly 2, right? So these are the kind of pictures that we want to have in mind. We are arguing that every time you have a ratio of less than 1. So let's try to change it a little bit. So is how now here the ratio is half, right? So let's try to keep a ratio of 1/3 and then let's see what happens. And now you see that 1 becomes 1 by 1/3, then this is 1/3 of 1/3, which is 1 by 9th, and then so on, right? So things become smaller. And what we are seeing here is the sum is approaching 1.5. So let's come back and see. In this case, A is 1 and R is 1 by 3, which is what the consecutive ratios between all the terms are. And it's telling us that the sum should approach 1.5, right? Let's check that once. Okay, so let's come back. So yeah, so in our case now on slide 17, so A is equal to 1 and R is equal to 1 by 3, right? So now in that case S will be equal to 1 by 1 minus 1 by 3, and that will be equal to 1 by 2 by 3, that will be equal to 3 by 2, that will be equal to 1.5. So you see, like this is what the formula is doing for us. It's telling us how to calculate the sum of an infinite series. Okay, what I would now tell you is as an exercise on slide 18. Now we'll go. Now that we know 1 plus 1 half plus 1 by fourth plus this, right? Like till infinity, it adds up to 2, right? What about, what if I started from 2 plus 1 plus, no, let's not do that 2 plus 1. Let's try to do 4 plus 2 plus 1 plus half. And then let's go on. You see the ratio is still the same. If you were to take a guess here, what would it be? Okay, and can you also match that guess with the actual formula? So one, take a guess, and the second thing that you should do is calculate it using formula. Okay, so and then try to see if these two match. So we'll talk about it next class. And the other thing that you do is try to calculate just the normal different thing, which is 1 plus half. So one sec. Try to calculate 1 minus half plus 1 by fourth minus 1 by 8 and so on till infinity. What will this sum be? Also again, take a guess. Try to, if you want, you can use Excel to plot it or something, and then also then calculate using formula. Okay, these are the two exercises. We'll discuss this next time. Okay, have fun. Bye bye.